Let's cover the concept of inflection points in this video. So the idea here is when the function changes from convex to concave or the other way. From convex to concave or from concave to convex. And let's see how that would look like on the graph. For instance, if we take this initial range over here, we can see that we have a convex shape. Look at the slope. It starts getting steeper and steeper as we start rising from the bottom, as we start rising from the minimum. It becomes steeper, steeper, but what happens after a threshold? What happens after this point over here? The function becomes flatter and flatter. It starts decreasing and it flattens out on the top. So the point where the function went from being steeper and steeper to flatter and flatter, it changed from being convex to concave. It changed from it increasing at an increasing rate to increasing at a decreasing rate. And this point where this thing changed is our inflection point. And mathematically, how can we prove when a function has an inflection point? Well, if we take the value where the second order derivative is equal to 0, and why would that be the case? Because it would neither be less than 0 to be concave, it would neither be higher than 0 to be convex, it would be just 0. Basically, it transitions. Remember, just like a function with the first order derivative is 0, when it's stationary, it's not increasing, it's not decreasing, it just stays. The same here, the function transitions from convex to concave or concave to convex, so basically it's just 0. And if to the left and to the right of that specific point, of that point where the second order derivative is 0, we have that the second order derivative switches signs, either is positive and negative or the other way around, positive and negative. Over here it means it used to be concave and now it's gonna become convex, or it used to be convex and now it's becoming concave. But that specific point, that's the transition point where the function is neither concave nor convex, like in this case over here, we're just transitioning. I hope this makes sense. In the next videos we'll prove all these things with our questions.